Hi guys, in this video I explain how quicksort works. Quicksort is a very efficient sorting algorithm that uses a divide and conquer approach. The division phase of quicksort is referred to as the partition phase. This is the phase in which the sorting occurs using a pivot element. It is sorted by determining the elements that are smaller than the pivot element and the elements that are larger than the pivot element. On average, quicksort is very efficient with a running time of n log n. Its time complexity, however, is O(n squared, but its worst case rarely occurs, and on average it's still very efficient. Let's go over an example. In this example, I have an array of 10 elements. I pick a pivot element. In this case, I just pick the last element in the array, but you could really pick any random element as a pivot element. Next, I iterate over the elements starting at the beginning of the array and keep track of a marker. The marker marks the beginning of the subarray where the elements are larger or equal to the pivot element. Let's see how this works. 4 is smaller than 8, so I increment the marker and go to the next element. 7 is smaller than 8, so I increment the marker, go to the next element. 2 is smaller than 8, I increment the marker and go to the next element. 9 is larger than 8, so I keep the marker at this position. Note that all the elements to the left are smaller than the pivot element, and the marker marks the beginning of the subarray with elements that are equal or larger than the pivot element. Now I inspect the next element 5. 5 is smaller than the pivot element, so I swap it with 9 and increment the marker. This ensures that all the elements that are smaller than the pivot element remain on the left side of the marker. 1 again is smaller than 8, so I swap it with 9 and increment the marker. 3 is smaller than 8, and again I swap it with 9 and increment the marker. 10 is larger than 8, so I go to the next element. 6 is smaller than 8, and I swap it with 9 and increment the marker. Now I swap the pivot element with the element where the marker is. Next I break it down into two subarrays. Again, I pick a pivot element for both subarrays. I iterate over the other elements in the array and determine which ones are smaller than the pivot element. Let's see how this works for 4. 4 is smaller than 6, so I increment the marker. 7 is larger than 6, so the marker stays right here. This marks the beginning of the subarray where elements are larger than the pivot element. I inspect 2. 2 is smaller, so I swap it with 7, increment the marker. I check 5. 5 again is smaller than 6, so I swap it with 7, increment the marker. 1 is smaller than 6, so I swap it with 7 and increment the marker. And 3 is also smaller than 6, so I swap it with 7, increment the marker. Here again, I swap it with a pivot element. I break it down. I have one subarray left. I pick the last element as my pivot element, which is 3. And now again, I iterate over the elements in this subarray. 4 is larger, so I keep the marker here. 2 is smaller, I swap it with 4, increment the marker. 5 is larger, 1 is smaller, I swap it with the marker and increment the marker. And finally, I swap the pivot element with the element where the marker is at. I have two subarrays left. I pick the pivot element, there's one element left, so I swap both with the pivot element. And the final array is the perfectly sorted array of integers. Now to recap, quicksort is a divide and conquer algorithm that does the sorting during the division phase. It is not stable by default, but it can be made stable, which adds to its complexity. The time complexity is O(n squared). The worst case, however, is very unlikely, so the average running time is n log n. I hope you enjoyed this video. Thank you for watching.